Hiya there, folks. This is a geometry video. It's chapter 10, section 6, and today we will be discussing secants, tangents, and angle measures. And so to get started, we have some vocabulary for you. And we have that a secant is a line that intersects a circle in exactly 2 points. It kind of reminds us of the definition of a chord. The difference with the chord being that it's a segment. A chord has 2 endpoints. So in this diagram, for example, the chord would just go from this endpoint to that endpoint, and it would just be that segment. But here we're talking about the entire line, so that's what we're referring to as a secant. Lines J and K are considered secants of this circle C. Now, when 2 secants intersect inside of a circle, so in this case, J and K are not intersecting inside the circle, they're going to intersect eventually outside the circle. But when 2 secants intersect inside a circle, the angles formed are related to the arcs that they intersect. So these arcs are the red here, the blue here. And they are related by this theorem, theorem 10.12. And it says, if 2 secants or chords intersect in the interior of a circle, like they do here on the inside, then the measure of the angle formed, like angle 1 for example, is 1/2, so it's going to be half, the sum, which when you say sum, it's going to be adding 2 things together, of the measure of the arcs that are intersected by the angle. So basically that means that in the case of angle 1, it's going to equal to half of the measurement of the intersected arcs, which would be the arc AB and the arc CD here. So you add those up together, divide by 2, and that should equal angle 1. Likewise, for angle 2, your intercepted arcs would be BC and also DA. So you add those 2 together, divide by 2, and that will equal angle 2. All right, so that being said, my pen is not yet ready to work with me here. So let me go ahead and go to the computer real quick. I'm sorry about this. We will manually close this little guy. So that will bring us to our first example here. And hopefully we can get this pen to work so that I can actually do the example for you. But in this first example, it asks us to find the value of x. And what we see, we have three different scenarios here. We probably want to make sure that our toolbox down here is kind of out of the way. So sorry, I'm going to have to figure out what's happening with this. It's actually a very short video, but if the pen won't work, it's just going to cause us some frustrations. Let's see if we can't get this situation resolved. Looks like we're I thought we were pretty close. There we go. I see some movement. Yummy. Thank you, pen, for working. Sorry about that for the rest of you. Okay, so here we go. We're going to go ahead and get started. Get us some nice color over here. So to find x, we can see that according to the theorem that we just said, theorem 10.12, if you take these 2 arcs and add them together and divide by 2, it should equal x. So what we're going to say here is that the value of x should equal 1/2 the sum of 130 plus 84. And so if we take this and add the 130 and the 84 first, we will get 214. And then if you take the 214 and divide it by 2, x will equal 107. So not very complicated, but there you go. Now in part B, we're going to kind of have to work a little bit backwards, because we know that this angle here will equal the half of the sum of 143 and 75, but the variable x is actually here, and we're not given what these arcs are. but we know that this is a line, so whatever this angle is, we'll call it angle CED. That angle plus x should equal 180. So for part B, it's going to be like a two-step process. So first, we'll just talk about the measurement of angle DEC. So this angle right here, this angle would equal 1/2 the sum of 143 and 75. And 143 and 75 is 218, and half of 218 is actually 109. So we know that the angle DEC equals 109. So that tells us that x, which is this angle here, plus the 109 should equal 180. And if we subtract the 109, then that leaves us with x equal to 71. And so that's how we do part B. Now in part C, we're going to work backwards. So in part B, we didn't really work backwards. We just had to have a two-step process. We had to find this angle first and then do the whole 180 thing here. But in part C, we're actually going to go backwards because the x is not the angle measure, it's actually the arc measure. So we're going to set up our problem as the angle, which is 110. So we're going to go 110, the angle measure, is equal to half the sum of the arcs, which in this case is 97 and x. And so we're going to solve for x here. So what's going to happen is you're going to want to multiply both sides by 2 to get rid of the half. And so you're going to get 220 equals x plus 97. And then simply just subtract the 97 from both sides so that we can get that the x value is actually equal to 123. And just like that, you do example 1. And so now we're going to let you go to the first do-it-yourself question. Here it is again. There are 3 parts. So make sure that you do them, and they're all going to be very similar to what we just did in the example. And then we will go on to our next example here. We have a theorem for that. And so our second theorem is theorem 10.13, 10.13, and it states that if a secant and a tangent, I remember that in the last section we talked about tangents. So here we have a tangent and a secant. So if a tangent and a secant intersect at the point of tangency, so here's the point where this line is tangent. So as long as this secant intersects through that point, it could be going in all kinds of different directions, but it has to cross through that point of tangency. When that happens, then the measure of each angle that is formed, so here's angle 1, angle 2, is 1/2 the measure of its intercepted arc. So for angle 1, the intercepted arc is AB. So the measurement of angle 1 would be half of the arc AB. And then for angle 2, it would be half of the arc, which would go from B to C to A, or you could go A, C, B. That entire arc, half of that would be the measure of the angle. So using that theorem, we have example 2 here. And in example 2, it says find each measure. So for part A, they want us to find the measurement of angle QPR. And so that's QPR, so this angle here. And based on the theorem, that means that angle PQ, or QPR, so the measurement of angle QPR would equal 1/2 of the intercepted arc, which is 148. So it's not very complicated. I'm not sure you can actually see my 148 there. Let's try that. There we go, now you can see it. And so if we take the 148 and divide it by 2, then that's going to give us that the measurement of angle QPR is actually equal to 74. Lovely. In part B, they want us to find the measurement of DEF. So D to E to F. But this time, unlike part A where they wanted the angle measure, they actually want us to find the arc measure. So from D to E to F. But again, they didn't give us the angle that's on this side to just do 1/2 of that or whatever. We have to first figure out the arc on this side, which is FD, and then we can take 360 because we know that the entire circle would be 360, and we can subtract the measurement of FD, and so there you go. So we're going to start with saying that 64, so the measure of this angle FDC is 64. I think I'll start over here. And we're going to say that that angle measure is equal to half of the measurement of arc FD, like that. All right, so that means that the measurement of arc D would be twice 64. So we times both sides by 64, and 64 times 2 would be 128. So then the measurement of arc FD is 128. And so that means that this portion here is 128. But what I'm actually looking for is DEF. But since the whole thing is 360, we're going to take 360 and subtract the FD, which we know is 128. And that'll give us the measurement of arc DEF. And 360 minus 128 is 232. So the measurement of arc DEF is 232. Lovely. So now you can go ahead and do it yourself, number 2, part A and B. And then we're going to go on to example trace. If this little guy will work with me. And before we get to example 3, we have another theorem, which is theorem 10.14, and it states that if two secants, that's one option. So here you have an example of two secants. The second, I see the comma there, so the second option is a secant and a tangent. So here we have a secant and a tangent, and then the third option, or two tangents. So here we have two tangents. So if any one of those 3 cases happens where those lines intersect in the exterior. So in our previous example, they were intersecting at the point of tangency. So in this case, they're intersecting on the exterior. So the first theorem was them intersecting on the inside. The second theorem was them intersecting at the point of tangency. Now we're talking about them intersecting on the exterior or the outside of the circle. When that happens, then the measure of the angle formed is 1/2, so it's very similar to that very first theorem, but it's actually 1/2 the difference, not the sum, the difference of the measures of the intersected arcs. So for each example, you can kind of see, here we have that angle A would basically equal half of the difference. So you would go with the biggest one, which is DE, and then subtract the smaller one, which is BC, so we've got that one. Here you have the same idea, so DC minus BC. And then over here, same thing, the larger one, which is BDC, and subtract the smaller one, which is BC. So again, the difference here being that it's going to be subtraction, not addition. So, for our example, they want us to find each measure again, and this time they want us to find the measurement of angle L. And so, according to the theorem, we know that the measurement of angle L will equal 1/2 the difference. So this big arc here is, we don't actually know what it is, but since we know that the entire circle is 360, then if we subtract 102, this blue portion here, then that'll leave us with the red portion. Okay, so that's the red minus the blue. So I hope that that didn't confuse you too much, but the 360 minus 102 is only there because it's telling me what the red portion is. And then remember that according to the theorem, you want to go red minus the blue. So that's kind of what happened there. So the 360 minus 102 is 258, which means that in this scenario, The red portion here is 258, and then I subtract the blue portion, that's what the theorem told us to do, and you're going to get 156. And then if you divide 156 by 2, you're going to get the measurement of angle L actually equals 70 ocho. Very nice. All right, so in part B, they want us to find the measure of the arc, not the measure of the angle. So we know that the measure of the angle out here is 56. So we start by setting up 56 is equal to 1/2. And then we want to find the difference of the red arc, which is CD. So the measurement of CD minus the blue portion, which is 95. So you have that. So what you want to do is you want to multiply both sides by 2 to get rid of the 1/2 here. So 56 times 2 is going to give you a 112. And then we're just going to simply add the 95 to both sides. So we get that the measurement of arc CD at the end of the problem is actually 207 degrees for the arc CD. Lovely. So that's how you do that. We will let you do it yourself number 3 here, part A and part B, and then we'll go to our last example, which is example 4. And in example 4, we're going to be using the same theorem, but it's just applying it to an actual real-world example or application. So the diagram shows the path of a light ray as it hits a drop of water. So here's my light ray, and it's hitting a drop of water. So the ray is bent, or what we call refracted. So you can see that as the light enters, it kind of bends this direction. Alrighty? So, and then it hits that edge and then it comes back out. So that's what's happening at points A, B, and C. So you can see A, B, and C there. And it's telling us that if the measurement of arc AC, which is this arc here, is 128, and the measurement of arc XBY, which is XBY, so this smaller one here, what is the measurement of angle D? And since angle D is exterior to the circle, then we know that the measurement of angle D is equal to 1/2 the difference of the larger arc, which is AC, which is 128, minus arc XBY, which is 84. So not really complicated, but there is what we need to do. So 128 minus 84 is actually 44. And then if we take half of 44, we get that the measurement of angle D is actually 22 degrees. And there you go. That is example 4 for you. So you will now do a similar thing here. Not a fancy word problem to apply to it, but you need to find the value of x here. And then here we have basically a summary of circle and angle relationships thus far. So you might want to copy this down into your notebook as well. And once you finish that, then you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.